Let's look at permutation. Question asks, how many 4-digit numbers are possible with the digits 1 through 8 if the numbers cannot repeat? So they've given us a permutation formula, but let's logically think about it. You discovered the answer as we went through. We have 4 placeholders for digits. Move those over. There we go. So we have 4 placeholders for digits. You have the options of 1 through 8, which means 1, 2, 3, 4, 5, 6, 7, 8. There are 8 options, right, to start. So once we've chosen that, we had 8 options. Well, whatever number we chose, like you said, we can't repeat. So now we're down to 7 options, then down to 6 options, then down to 5 options. And there's only 4 placeholders, so this should be our answer as we go through it. I think we calculated it already. Yes, we did. 8 by 7 by 6 by 5 is 1,680 options. So we should have 1,680 different 4-digit numbers with no repetition. This is also the idea of a permutation. Okay, the permutation being that we have 8 digits. Okay, and how many different ways can we choose 4 out of those 8 possibilities? Okay, so when our n value is our 8 options here. So this is our n is 8. And our r value is going to be our number 4. We have 4 digits, so how many different ways can we choose the different 4 numbers? When we put it into the permutation, we have 8 factorial over 8 minus 4 factorial, right? Because our 4 was our r value, our 8 was our n value. And when we do that, we're going to see how that ends up being there. You go 8, 7, 6, 5, and then we have our 4, 3, 2, and 1. And the reason in our formula they don't exist anymore is because 8 subtract 4 is 4. So 4 factorial is 4 by 3 by 2 by 1. And in terms of calculating this, we know that these eliminate each other. So you end up at the exact same answer of 1,680, whether you do this by thinking logically through like a fundamental counting principle, or you put it into a permutation, you end up at the exact same value. Add to that, they also asked us, let's say, it's a full page. Let's say they ask us number of even, okay, and then with that, so we'll call that our part B, our part C, the number of odd numbers, okay. I'm going to use our thinking one, or our fundamental counting principle. Well, let's say we just count in the reverse order. We normally start with our numbers here. Well, let's say we're going to start with this as a right first digit, which makes sense. We have 1 to 8. There are 8 options. And then as we go to the left of our 4 digits, we do our 6 and then our 5. Well, when it comes to even and odd, the only digit that's important is this, right? So what are the options? Well, we can write them all out. We have our odd options and our even options. Odds are 1, 3, 5, and 7. And evens are 2, 4, 6, and 8. And those encompass all the numbers from 1 to 8. And they pretty much split right down the middle. So whatever our value is for even, we have our 1,680. We split it down the middle. Right? And that's going to give us 840. So 840 are even, and then 840 are still odd. Okay, so that's how we can logically come to the conclusion that those two will split between each other.